our next headliner is a tenured associate professor at the Department of Computer Science and Engineering at the Speed School of Engineering at the University of Louisville. He's the founding and current director of the Cybersecurity Lab and an author of many books, including Artificial Superintelligence, A Futuristic Approach. After his session, we're actually delighted to be giving away just a limited number of signed copies of his new book, and I believe it is at the World Summit AI sales area, and you'll find that on the expo floor at stand E11. So that's E11 if you're interested in a signed copy of his book. But before you make that decision, you can listen to his talk, which is called AI Unexplainable, Unpredictable, and Uncontrollable. Please welcome Dr. Roman Yampolskiy.
All right, can you hear me? Excellent. Thank you so much for coming to my talk. It's a great honor to be able to share my research with you. I work on AI safety and security, which means when everyone else presenting here succeeds, it's my responsibility to make sure AI they create behaves. Specifically, I look at advanced AI systems, systems which we don't have yet, artificial general intelligence and artificial superintelligence. Let's go to slides, see if that works. Slides, do I need to do something magical? Here we are. So that was our first slide. Just about a year ago, a system was released which really changed everything. A complete game changer in terms of being probably the first system where people said it's showing sparks of generality. It's not a narrow system. It's a system we can call pre-AGI. It was able to outcompete, at least on standardized tests, a lot of college students, graduate students, medical law students. And if it's showing signs of generality, if it's called pre-AGI, how long before we actually get to true AGI, true general intelligence, systems capable of really doing anything you can? If you listen to leaders of those top AI labs, Anthropic, DeepMind, OpenAI, they are saying we are maybe 2-3 years away from true AGI. That's not a long time. If you look at prediction markets, we are now showing maybe 2026 as a date for AGI, which is pretty much the same prediction. Are we ready? Are we, in terms of technical solutions, prepared to deal with something so advanced, so capable? A lot of people, scientists, business leaders, political leaders, are very concerned about this technology. In fact, there are thousands of scientists who signed letters saying that they're so concerned, they think this is as dangerous as nuclear war, nuclear weapons. Meaning there is possibility of existential risk, meaning all of us may not survive this technological development. So this is what I work on, the AI control problem. We don't have a very good formal definitions for it, and people have different local explanations for what they're working on, even if they work on AI safety. More interestingly, we don't even know what type of problem that is. Typically in computer science, we know that a problem is solvable or unsolvable, belongs to a specific computational difficulty class. Here, we don't really know if it's solvable, partially solvable, undecidable. We just don't have a good answer yet. The goal is to stay in control while getting benefits of this advanced technology. We want to make sure we do not regret building those systems. So what is the state of the art in our understanding of this problem? Here I look at 3 different experts a father of machine learning, Turing Award winner, an outsider AI safety expert, and a top industry alignment expert. And they give 3 different estimations for the difficulty of a problem. The Turing Award winner says he has no idea how to solve this problem. The outside expert says, well, it's solvable, but not with the brains we have, not with the time frame we got. And the industry guy says it's so easy, we're going to do it for sure. So that's not very encouraging. We would like to see a little more consensus on it. And this is where my research comes in. I'm trying to understand, well, how hard is this problem? The way I approach it is I think we need a toolbox of capabilities to control AI. We should be able to explain how it works, comprehend those explanations, predict what the system is going to do in some detail, be able to verify the code, proofs behind safety mechanism, and many more similar tools. So I look at each one of those tools, and I see, do we have that capability already? Are there upper limits on how well we can do this? Are some of those things impossible to get? And so I'll show you a few results. Those are published papers. Those are not preprints, where we talk about upper limits and those capabilities. First one is explainability. There are things we cannot comprehend as people, and one of those things is to fully evaluate a large model. It has billions of nodes, trillions of connections. It is not even surveyable for a single human brain. So model as a whole, which is the real explanation for how decisions are made, are not comprehensible. We can create something like Closey compression, where you're given a top 10 reasons a decision is made. It was probably useful to have it. It will give you some idea of why the system did what it did, but you lose some of the information. You are not getting full picture about what is happening. Another result is unpredictability. Unpredictability of, so what is showing and what I'm getting is not the same. Can we align with main slides? Let's try it again. OK, so it's up to me to control it. See, we can't even control a clicker. What are the chances we'll control superintelligence? We can do a pretty good job predicting what a smarter agent will do. If you're playing chess against a better player, you know they're going to win. But you don't know specifics about how they're going to get there, what specific moves they're going to take at any stage in a game. If you could predict specific moves, you would be playing at the same level. You would be just as good. So the assumption about the other player being superior to you is the wrong assumption. So we cannot have specific understanding of how a system will achieve its terminal goals. There are many ways to get to the same set of goals, so it's possible to get quite a few side effects, dangerous side effects, if we don't fully understand what that path is. There are also limits on verifying code and mathematical proofs. You may have a perfectly good design, but its implementation may not be accurate. We have some capability of proving mission-critical code to be correct. It's very expensive, very difficult, and it works well for static algorithms, deterministic algorithms. We have no capability of doing it for learning systems, self-modifying systems, systems undergoing interactions with users. All the proofs we do have are with respect to a specific verifier. So we're not saying that the proof is correct. We're saying that this other piece of software thinks it's correct. And who proved that piece of software? Some other verifier. Maybe it's a human. Maybe it's a community of mathematicians. But at the end of the day, all you have is infinite regressive verifiers. And you can make a proof much more secure by putting more resources in it, but you never get 100% results. So this is kind of a sampling of some of the main results. In case you really love impossibility results and AI safety and want more of them, we published a survey of about 50 of them in a very good journal, talking about all sorts of tools we may never have, or have only in a very limited way, for working on the control problem, which means that the problem itself, control problem, is likely unsolvable. Now, depending on how you define control, are you talking about direct control following orders, or indirect control, something like an ideal advisor, we have different proofs for showing that full control is impossible. You may get certain benefits out of a system, but there is a direct trade-off between capabilities of a system and how much control you retain over it. And we were able to publish it both as a journal paper and popular articles in Time magazine and many others. Last month, I also published a book which summarizes a lot of that research. So far, it's doing well. People seem to enjoy it. We will be giving away free copies, and I'll sign some of them, which may decrease the value of the book, given my handwriting. But yeah, if you're interested, it's written for someone with general understanding of computers. It's not highly technical. And essentially, what we're noticing is all the safety work right now is kind of like the picture, the cover picture there shows. We have this large model, which is not very well aligned with any human preferences. It's kind of very raw and ugly. And we put filters on it. We tell the model, no matter what you do, don't say this word. This very bad word, don't say it. And the model does a great job of not saying that word. But under the hood, under the smiley faces, it's still the same model. And then we open source it. Then we make it accessible. Some people may decide to take the mask off. So before I go to the next slide, how many of you think we can indefinitely control superintelligent machines? Raise your hand. Now look around you. Let's see what surveys of social media followers show. So this is very small n size. This is not scientifically significant. This is not science. This is my Facebook and Twitter accounts, X account. But nerds who follow me, only about a third of them thinks it's possible to control superintelligent machines indefinitely. That's not a lot. And you saw how many hands were raised around you. So this may be the state-of-the-art understanding of that problem right now. We're building something we don't think we can control. And we're trying to accelerate that process because we feel we're not getting there fast enough. If you have a system which is so capable, it can do novel research, it can do synthetic biology, nanotech, but you are not controlling it, there is a chance that it may cause a very big accident, an existential crisis. And people call it P-doom, probability that we will screw up really bad. And you can see the different probabilities, different experts assigned to this. I think the keynote presenter for this conference tomorrow is at about 20%. And many are at 20, 30, or more. Now, those are insane numbers. If this was about 1%, that would be insane to bet all of humanity on maybe some financial benefits. But we have 20, 30, and some people are close to 1. Now, that guy is an outlier. Don't listen to him. But those are unacceptably high numbers. And I want to tell you why I think it's actually very close to 1. It's never 1, but it's getting close. We are working on creating, essentially, a system which will require a perpetual safety device, by analogy with perpetual motion device. It's impossible to do. We're not just securing GPT-5. we need to make sure that GPT-50, GPT-500, all the other models which are continuously learning, interacting with users, self-modifying, have no bugs in them. Because the difference between AI safety for narrow systems, as in cybersecurity, and safety for superintelligent systems is fundamentally how many chances you get to screw up. With cybersecurity, if you made a mistake, you reissue passwords, somebody gets a new credit card, it's embarrassing, maybe some Bitcoin is gone, but the world goes on. With a superintelligent system, we only get one chance to get it right. And if we don't, that may be the end of it. The last chance to properly solve that problem. Many speakers at this conference talk about copyright for training data. They talk about privacy issues. But here we're talking about existential risks and suffering risks as a result of this. So for that reason, I'm not too optimistic. We have never successfully created 100% safe anything, especially software, and especially software of this complexity, where the software itself is smarter than the designers. So at this point, I'm happy to answer some questions. I'm sure there are many. And after we enjoy this Doom talk, we'll have lunch.
Thank you very much, Roman. We are tight on time, but we do have time for at least one question. So raise your hand. Oh, person here, you're the lucky one. and right to celebrate as well. Stand up, tell us who you are, and ask. Everyone's really keen to know what your question is now, given you've got this prime slot.
Sure.
Go for it.
My name is Lincoln Chand. I'm from Roche Pharmaceuticals in Toronto, or based in Mississauga, I guess. My question is, so since there's no chance of getting it right, should we just roll over and give up now? Or what is the hope? I'm hoping that there is some hope that you would see for us to do something.
So I bring a lot of problems, not too many solutions. It seems right now, given that no one in the world has a working safety mechanism in place, or even a prototype for how one might work which scales to any level of intelligence, maybe creating superintelligent or general AI as soon as possible is not a good idea. We can get a lot of benefit, pretty much all the benefits, from narrow systems. They can be used for medical research. They can be used for example, protein folding problem was addressed beautifully with a narrow system. So I would suggest not working directly on making more capable systems if you don't have a safety mechanism already lined up. Will it actually happen? No, of course not, but it would be a great idea.
Well, thank you very much. Please give a huge round to Dr. Roman Yampolskiy. I also want to remind you that Dr. Yampolskiy is going to be doing book signing at E11 on the Expo from 1 to 1:30 if you want to swing by there and get a copy of the book. Thank you very much. And as you may have detected, it is now